We want to look at another stoichiometric calculation for gases. We need to remember to label everything so we know what we're looking at. So I'm looking for a volume of chlorine gas, and that gas is already measured in torr and degree C. So everything associated with the Cl2 comes first. Then we have this one lonely guy that has to do with NaCl. Well, we want to get the NaCl into chlorine, and then we could just use Pb equals nRT. So let's start with that. We've got 28 grams of NaCl. When in doubt, the first thing you always convert to is moles. That's correct. So we're going to go to moles of NaCl, which is 58.44 grams of NaCl. Now we need to get to moles of Cl2, so we have to use a mole-to-mole conversion. So I'm going to write in what we want for sure on labels. And then I come up here, and for Cl, the coefficient is 1, and the coefficient for NaCl is 2. I'm going to do this calculation. I'm going to get 0.24 moles of Cl2. So now we can use PV, N, R, and T. We just found the N at 0.24 moles. We're looking for the volume. It says we have a pressure, but we notice, uh-oh, it's in torr. So I'm going to have to take that number, divide it by 760 to get my atmospheres. We've got the R, that's a constant. The temperature, oh, it's not liking us. It's in degrees C, so we've got to add 273.15 to obtain 308.15 Kelvin. Now I've got everything in the correct unit, so whew, I can finally plug this into PV equals nRT, but we just want the volume, so it's going to be nRT over P. And I'm going to plug in everything that I know. Uh-oh, the T's going to run off the page. There we go. And then the pressure, of course, is going to go on the bottom down here. And when I do this calculation, my final answer needs to have two significant figures, so I come out with 6.7 liters.